Gauge blocks are one of the more unique measuring tools in the shop. Not only can they be used to measure directly, they can also be used to calibrate other measuring tools such as micrometers. Gauge blocks come in various sized sets. This is one of the more common sizes. It's an 81-piece set. It ranges from about 50 thousandths on up to practically up to probably 6 or 7 inches, or if you lay them out flat you can probably stack up the whole set if you had the time or the ability. They also come in various grades. This is a shop grade. Some are called B grade. There's also higher grades such as inspection grades or lab grades. But for general shop use, the B grade or shop grade is all you need. An 81-piece shop grade set, just an inexpensive import set, is perfect for the shop environment. Let's go through a little tour here. The first block is 50 thousandths thick. The next 10 blocks are a tenth plus 1/10,000th up to 0.1009. These blocks in this area range from 0.101 up to 150. And then they go up by 50,000 in 50 thousandths increments from 200 up to 950, and then by 1 inch increments after that. What are gauge blocks used for? Well, lots of uses. They're a very versatile tool to have. A common use is to measure the width of slots on the milling machine. If you're milling slots in a part and you want an exact width slot, you'll make up a set of gauge blocks to whatever width you need, and you can use them as a gauge to gauge the width of the slot as you mill it. And nice thing about measuring slots with gauge blocks is they can't be fooled by taper in the slot. If your end mill deflects a little bit and you get a bit of taper going, it doesn't matter. You can't fool them. I mean, if the slot's not big enough at its smallest point, the gauge block won't go in. As I said before, you can also use them as micrometer standards. Your larger micrometers, you see we have a 1 inch, so you could set a 2-inch mic. You could calibrate it to the 1 inch, and then you could calibrate your 3-inch to the 2-inch standard, all the way up to 4-inch, or ring them together and do larger mics. So they're great for calibrating micrometers. You can use them to set angles with a sine bar. Build up various stacks, put them under a sine bar, and using trigonometry you can calculate the angle on the sine bar for inspection or for use in the milling machine, however you want to do it. Another common way to use them is on a granite surface plate. For comparison, you can build up a stack of blocks, and then using an indicator you can compare the height of the stack of the blocks to an existing part and see how close your dimensions are. Let's talk a little bit about the care of gauge blocks. They're pretty fragile critters. They're very precise, as I said, or did I say they're accurate to about 6 millionths of an inch on size. So they're probably the most accurate, most precise tool you have in your shop. So they have to be treated with care. They're real susceptible to corrosion. So I always keep my set greased up whenever I use them. I keep a little bit of grease right here in the set. And I clean them off, use them. When I'm done, I recoat the surfaces with grease. Otherwise they'll corrode. These cheap sets like this are not plated. They're bare steel. So if they're stored in a humid environment, they're going to corrode unless they're greased up. They don't like to be dropped. I mean, if you drop them on a surface plate or you drop them on a machine, raise a little burr on the edge of them, then they're not going to be accurate because that burr is going to prevent the blocks from fitting together properly. Sometimes some sets have little pieces of granite stone in them you can use to dress burrs off. This one doesn't. You can also, in a pinch, you can use a surface plate. Make sure it's clean. Put a little alcohol on it or something. You can kind of dress off a high spot. It's best just not to drop them, though. Another enemy of a gauge block is dust. When you use them, before you ring the blocks together, you want to make sure the surfaces are perfectly clean. I always clean the grease off with some solvent and a rag, and then before I ring them together I wipe them on my wrist. Make sure there's no dust or grit on them. So let's talk about building a stack of gauge blocks. That's what the video is all about, right? So how do we go about building a stack of gauge blocks? Do we just start grabbing random blocks out of the set and stack them up and hope for the best, or is there a procedure that we can follow that'll make it a little easier? Well, as it turns out, there is a procedure, and if you can do basic subtraction, you can build a stack of gauge blocks. Let me give you a little example here. Let's say we wanted to build a stack of gauge blocks 1.5573 inches high. Okay, the way we go about doing it is we look at this rightmost digit in the number. You see that's a 3, and it's in the 1, 2, 3, 4th decimal place. That makes it 3/10,000ths of an inch. Well, we're not going to find a 3/10,000ths of an inch thick block in our set, so we have to go take the next best thing. If you remember, these first 10 blocks here are in 10,000th of an inch increments, plus 1/10. So we look for this block right here. I see we have a 0.1003 thick block. That's going to be our first block. Let's write it down, 0.1003. Do subtraction. 3 minus 3 is 0. You can see we got rid of that rightmost digit. 7 minus 0 is 7. 5 minus 0 is 5. 5 minus 1 is 4. That leaves us with 1.457 inches. Look at this right digit again. It's a 7. Okay, it's in the 1, 2, 3rd decimal place over. That makes it 7/1000ths of an inch. There are no 7/1000ths thick blocks in here, but there are 0.107s. Remember, all these center blocks here are 0.101 through 150. So there should be a 107 in there somewhere, right about here. Let's write that one down. 0.107. Do the math. 0, 0, 5, 3, 1. That leaves us with 1.350. Well, remember I said these middle blocks here are 50,000ths increments, so there should be a 350 in there somewhere, and sure enough, 350. Let's write that one down. 350. Subtract 0, 0, 0, 0. Leaves us with 1 inch. The upper blocks are 1 inch increments. Starting with 1 inch. Okay, so we got our 4 blocks. Hopefully we stack these up, we'll get 1.5573. Alright, how do we make a stack of gauge blocks? Well, first thing we do is clean all the grease off of them. I like to use alcohol. It's a little easier on your hands than petroleum solvents. So wipe all the grease off of them. As I said before, all my blocks are stored well greased so they don't corrode. All right, once you get them cleaned off, then what you do is you hold one in each hand and you wipe them off on your wrist. And what that does is it gets all the lint from the rag or any extra dirt or debris off of them, so you can wring them together. And the way you wring them is you put one block, corner of one block in the center of the other block, push them together, and you cross them and give them a little twist as you're pushing them together. And what that does, remember I said these were really super accurate blocks. They're accurate to within millionths of an inch, and they have flatness to boot. And what happens is when you wring them together like that, all the air is forced out from between them. So what you're left is air pressure all around them that holds them together, and they stick together. As a matter of fact, the better lab grade blocks, if you wring them together like this and leave them set overnight, the molecules will actually grow together and 2 blocks will become 1. Not a good thing for the gauge blocks, but it's kind of a cool concept. Alright, let's finish up here. Let's wring the next 2 together. Okay. Bring the last 2 together. Alright, that gives us a stack of gauge blocks. I always like to just check them with a pair of calipers as a little sanity check. See if my math is right. 1.557. Okay, we're going for 1.5573. I think I'd trust this over this. Okay, so that's one example. Let's clean up the board here and take a look at another example. I really need some dry erase markers, I think. Alright. Suppose we wanted to build a stack of gauge blocks 1.5873 inches tall. Alright, same as before, we'll look at this right digit. It's a 3/10,000ths place. So we'll use the 0.1003 block. That's this one right here. Write down 0.1003. Do the math. Leaves us with 1.487. Now there's always an exception to the rule. Okay, this time we're going to have to do it a little bit differently than last time. Remember I said these center blocks in through here are all in 50,000ths increments. That's 0.05. So if we look at this second decimal place here, when we choose the block to wipe out this 7, we have to keep an eye on the second place. We want to make this turn out to be either 0 or 5. 0 or 5, 50,000ths increment. Alright, so 107 won't work because 8 minus 0 is 8. That won't work. But let's see, what other blocks do we have that end in 7? 147, 8 minus 4 is 4. That won't work. How about 137? 137. 8 minus 3 is 5. There we go. Alright? Let's write down 137. 137. Do the math. 0, 5, 3. 1.350. See, now our second decimal place here is a 5. So I think now we've done this before, right? We know what's going to happen. We're going to find a 350, which I already have out here. .350. Now we should have a whole bunch of zeros to work with, right? Leaves us with 1 inch. There's your 1 inch. We're good to go. Stack all those up, we'll get 1.5873. That's about all there is to gauge blocks. I mean, I picked 2 examples. These are the 2 issues you run into when you stack them up. The first one is pretty easy. This one has that little extra step you have to watch out for in the second decimal place. But other than that, that's pretty much all there is to it. I'm going to grease these babies up and put them back in their resting place. You guys get yourself a set of gauge blocks and give it a try.